Welcome to this presentation, Using Simulation in Decision Analysis, Part 2. In this presentation, I'm going to demonstrate a very popular simple simulation method called Monte Carlo simulation. Monte Carlo simulation is probably one of the most widely used simulation methods out there. Uh, One reason why it's so popular is because it's usually very simple to build and simple to use. But Monte Carlo simulations could be a lot more expensive. This is really a broad class of computational algorithms that rely on random sampling to obtain numerical results. It's kind of broadly defined, but there's a lot of different types of Monte Carlo simulations out there that tries to address certain type of problem or a certain class of problems. So I'll give you a few example, a very brief example. So in a nutshell, like Monte Carlo simulation is forecast by simulating the past and applying it to the future. So that's kind of the main objective. So very simple examples, or the simulations themselves are probably much more complicated, and they're more involved. But where Monte Carlo simulations have been used in the past is, for example, the COVID-19 infection spread prediction. When the pandemic hit, how will this virus spread throughout the world, right? So you can use a Monte Carlo simulation to see how it will propagate throughout different regions of the country and beyond. Options trading finance, it's been used very broadly in different applications in finance. Production planning, based on Monte Carlo simulation, can you plan your production, right? There's also collision risk management in restricted airspace. So can you simulate, using Monte Carlo simulation, can you basically predict when a collision will happen so that you can prevent it? Another example is the risk analysis of gas storage facility. So, if you have a bunch of these, gas storage facilities, let's say in a port, based on Monte Carlo simulation, what's the risk that there'll be an accident or a fire or some kind of disruption? So there's a very wide range of cases where Monte Carlo simulation has been used. In our context here, we're going to do some very simple examples to demonstrate the concept. You can actually apply it in your own problem. Some of the main steps in Monte Carlo simulation. It's very similar to other types of modeling. You first have to start with a problem definition and setting the objectives. And then you have to identify all of the inputs. And you gotta also you have to identify and basically figure out how these different inputs interact with one another or how they affect one another. What are some of the coupling behavior? And then you have to create the input probability distribution. This usually is based on past historical data. And then you generate a set of random samples or random values, for your inputs, and you run your simulation, okay? And then you analyze results, and then you interpret and validate. Pretty standard kind of format. Obviously, this could vary depending on the scope and the complexity of what you're trying to simulate. But in a nutshell, these are like the common steps if you're trying to create a Monte Carlo simulation. So let's demonstrate Monte Carlo simulation using a very simple example. Let's say our topic here is new product launch. Okay, so consider a scenario where a consumer electronics company is assessing the financial viability of a new product. Let's say it's a wearable fitness tracker. They want to figure out whether this is worth launching or not. The market for the device is very competitive with a highly variable consumer demand influenced by seasonality and marketing effectiveness and competitor action. So, you're going to assume that this market is extremely competitive and it's very sensitive basically to a lot of different factors. The consumer demand can change based on, there's some seasonality, so based on the time of the year it may change. It could also change by how good our marketing campaigns are, and it could also depends on what we can actually directly control, what our competitor does. Costs associated with manufacturing are subject to fluctuations due to changes in material costs and supply chain uncertainties. Then we're going to perform Monte Carlo simulation to estimate the profitability under different scenarios. So let me just kind of drill down to the main points here. Okay. Ultimately, we want to simulate basically the profitability of this product, right? At the end, the output should be some type of profit. The inputs here are some of the things that we can control and also variables that we know have some variability or have some random behavior. So the market demand, for example, is something that's variable, and there's some probability that, for example, it'll be high or uh, low, medium, etc. The cost here are also variable, right? Because it can fluctuate due to changes in material costs and supply chain uncertainty. So you have to be able to identify basically the input variables here and see what has random behavior, okay? Because that's what you're trying to capture with the simulation, okay? And based on those factors, then can you then simulate this and then get an output, which is the profits here, and then do some kind of analysis on that profits. So I'll pick one of these. I'll pick one of these input variables here, the demand for the product. Let's say based on historical data, the average for the average demand for the device, let's say it's 10,000 units within the first year of launch. Let's say for a standard, and then the standard deviation of this demand based on previous launches of similar devices, let's say it was 2,000 units. Unit sale price, let's say, so this is a histogram of the demand of that device. So the average, it's not 100%, right? It's not always 10,000, right? Okay, it varies, right? And that histogram, the diagram you see on the right there, okay, this shows you the distribution of the demand of similar products in the past, right? So this is a normal distribution. The average or the mean is at 10,000, so it's this value right here. The spread is basically determined by that standard deviation of 2,000. So it kind of shows you how variable this demand's been. Okay. The unit price can also vary. The unit sale price typically ranges from $50 to $70, depending on competitor pricing and market saturation. So the price on how much you charge for this device also changes based on market conditions. You might price it low because of high competition, or maybe you price it high when you have more market power. Um, so in this situation, we're going to assume that the unit cost is influenced by volatile material prices and manufacturing efficiency. Averages $30 per unit with a standard deviation of $5. The second bullet there, unit price, it ranges from $50 to $70. We would have to make an assumption on what that distribution will look like. Based on what's given right there, it's probably not normal. It's assuming some other distribution. The last bullet, the unit cost though, this is a normal distribution because it's got we're going to assume it's a normal. It's got an average of $30 per unit and a standard deviation of $5. Right? So we have three input variables that we know has some random variability or some random behavior to it. We're going to take these three inputs now and then create a Monte Carlo simulation to basically get an output, which is our profits. Graphically speaking, okay, our so-called model here, right, our Monte Carlo simulation model is really you're combining three different random variables in a sense, right? Okay, the first one is the product demand. It's got a normal distribution with a mean of 10,000 units and a standard deviation of 2,000 units. Okay, as we saw previously. Okay, the two other variables that affect what we're trying to get is the profitability, right? The profits, right? So what affects profitability? It's the product demand, and there's other variables, right? In our case, the other variables are the unit price. It ranges from $50 to $70, and the third variable here is the unit cost. Okay, and that again varies depending on supply chain conditions, etc. The average unit cost is $30 with a standard deviation of $5. Based on those three inputs, our model takes in those three inputs and basically calculates a profit value, expected profit, right? Or we're going to get the profit for that specific iteration, and then we're going to get a set of outcomes based on a series of trials, okay, which we'll demonstrate here in a second here. Okay, so you take all those three inputs, and ultimately you're taking that in to simulate the profits for this product launch, using a Monte Carlo simulation model. Here's a snapshot of the simulation results. So, just like in previous cases, this one, again, it's not very complicated, so you can do this in a spreadsheet. You're gonna simulate the demand. You generate a set of random numbers. You create the random demand. You then generate another set of random numbers for the sales price, and then you generate another set of random numbers to simulate the cost. Okay. Based on those three variables, you can calculate the profit. Okay. And then in this case, for these 100 trials, so it's like basically I've simulated this product launch 100 times based on a different demand, different sales price, and different cost. Okay. The average profit here is close to 300,000. The minimum I get for any single run or any single trial is about 90,000, and the maximum profit I got from any of these trials was above 600,000. The standard deviation of this profit was about $97,000, right? So this gives us a result, a distribution of what the profit would look like, okay, if you were to simulate this, right? So that the histogram on the lower right corner, that is the distribution of the profits of the 100 trials. So roughly speaking, we expect to make about $300,000 off of this product launch. But again, it could vary, right? Depending on some of these factors that we can't control directly necessarily, right? The demand, sales price, and cost. So it could range from, as low as just under 100,000 to as high as 618,000. And you can kind of tell what that distribution of profit looks like based on the histogram. Okay. Now, why we would use a Monte Carlo simulation here, one of the added values here is that once you build this, we can change the input parameters and rerun the simulation as needed. You run what are called if else scenarios, right? So what if the demand was a lot higher? What if the sales price is a lot more variable? The range is a lot wider. Or what if the cost is a lot lower than expected, right? And how does that change our output? Which I'll demonstrate in a second on the spreadsheet itself. But this is basically a very simple single output from a Monte Carlo simulation.
Welcome to this video. In this video, I'm just going to demonstrate how to use this template here. This file is called MC_example. This is an add-on to the previous videos. The the problem that I'm capturing here in this template is the same one that I went over in the previous videos. We have a new product launch, and there's some uncertainty or variability in the demand, which is this column right here. Okay, so we don't know exactly what the demand is going to be. We have some estimate from previous history that the average demand is 10,000 and the standard deviation is 2,500, and it has a normal distribution. Okay, so we don't know exactly, but we know we have some probabilities associated with certain demand values, and it's got a normal shape. The sales price is also uncertain, right? We know it's some value between 55 and 65, and we're going to assume it's got a uniform distribution. The cost is also has variability. It's got an average value of 40 and a standard deviation of 5, right? And that's represented by this column here. So let me just quickly go over like how I'm calculating these values or generating these values, right? So for the demand, I'm just using the built-in norm.im function in Excel. So you see right here, I'm using that built-in function. The rand function here generates a number from 0 to 1, and that's the random number. Based on that random number, Excel is going to basically map out a value from a normal distribution with a mean of 10,000 and a standard deviation of 2,500. Okay, so that's how it's generating the 6,720.07 value from a random value. Let me just write out the rand function out here to kind of see. So the rand function, it's some value from 0 to 1 every time, right? Okay, so based on that value, let me just put that one more time here. Okay, based on that value, it's basically mapping out the corresponding random value from a normal distribution. Okay, each row here in this table represents a product launch, right? So basically simulating 100 product launch because since there are 100 rows here, okay? So I'm doing this 100 times, okay? The sales price it's not normally distributed, it's got a uniform distribution. That means that every value from this minimum to the maximum has equal probability. So if you look at the equation I set up here, the smallest value is the minimum, so C2 is 55, plus the difference between the max and the minimum, so 65 minus 55, 10, times the random value, right? So let's say my random value was 0, then I would get my minimum value 55. And if my random value, let's say, was 1, I'm going to get my maximum value 65, right? Because it's 55 plus 65 minus 55, which is 10 times 1, right? So it's 55 plus 10, you get 65, right? So every iteration, you're going to get some value from 55 to 65 with equal probability. If you look at the cost column, okay, this is also a normal distribution, same as the normal distribution, right? Or the demand column, right? I'm using the built-in norm.m function. There's a random value here, and we have to give it the mean and the standard deviation of the normal distribution. So it's generating a value between generate a value from a normal distribution with a mean of 40 and a standard deviation of 5. And the profit here is simply the profit margin. So sale price minus the cost times the demand, right? So every time this runs, it's simulating 100 product launches. The histogram here is just a histogram of their profit column. So this histogram is the histogram of this profit column here. Okay, the average profit it's around 29,000 for this set of 100 trials. Gives you standard deviation, etc. Why would you build one of these? Again, this is a very simple model, right? But one of the main advantages of having a simulation model is so that you can run a lot of what if scenarios. So, for example, let's say the demand for this new product was a lot higher than we thought, right? So let's say it was 12,000 instead of 10,000, right? When we do that, you can kind of now tell if you rerun this, right? You see the average profit is higher. There could be some, a bigger standard deviation here, right? But you can kind of see the effect of this increase in demand here, right? Let's say the standard deviation was actually higher than we thought. Let's say it was 3,500. That also has an impact, right? So you can kind of see what happens to that curve there. Um, maybe this was maybe the standard deviation was relatively small, or but then also the average demand was actually a lot smaller as well. Let's say this was 9,000. So you can kind of see what happens there, right? So let me restore these values back to our original values here. Let me test out the cost sales price parameter. Let's see what happens like if the sales price the range was a lot wider than this $10 range from 55 to 65. So let's say this was 45 instead. Okay. So you can kind of tell right away the average profit value goes way down. The standard deviation seems like it's affected as well. Things can go a lot more wrong here in a sense, right? Let's say the maximum was actually a lot smaller as well. Let's say this was now 55, and you can tell even more is a bigger impact there, right? Or it could have been a narrower range, right? So instead of being 55 to 65, let's say it was 55 to just 60, right? And you get a different result here as well, right? Let's check out the cost parameter. Let's say the standard deviation on this number was actually a lot higher than we initially thought. Let's say it was 12, right? So you can kind of see what happens to that curve there. It's a lot flatter distribution. The average profit seems like it's about the same as before, but you see that min profit number, and look at the standard deviation, it's much, much bigger. So let's say though the cost was actually, you know, the standard deviation got higher, so variability got higher. Also, the average value also increases. Let's say to 50, right? Now you can see the bigger impact there as well, right? So you can see how sensitive your profit's going to be with respect to this cost parameter, right? So just putting some context here, let's assume like your supply chain was more severely impacted by some natural disaster that we didn't anticipate. So as a result, the actual cost per unit was a lot higher with a higher variability, so higher standard deviation. You could simulate that here and see what the impacts are. Right? So hopefully this is a good kind of simple overview of how you would use a Monte Carlo simulation. You can play around with this file. In a subsequent video, you will get a chance to build one of these on your own, but this should be a good starter for you to get started. This is the end of the video. Thank you for watching.